Okay, so how is everyone today? Good, I hope.
A lot of teachers are giving extra credit to the kids that show up on Friday.
Yeah?
Just a couple extra points.
Couple extra points?
Recently taken midterm or something.
Yes?
When will our midterm be?
That could mean, I could interpret that two ways. So your exam grades, the things that you did on Wednesday, they'll be in by the Wednesday after we return. So that is to say 5 plus 7 days from now. Then a separate question, which you may also be asking, is when will I submit your midterm grade to the university? And I'll probably do that today. For those of you that don't understand what that means, is that the university asks for instructors to submit grades twice, once in the middle of the semester and once at the end. The one at the middle of the semester doesn't mean anything, much anyway. You know, they would be concerned if I gave you an F in the middle of the semester. But in the end, if I followed it up with an A at the end, then they don't care. It doesn't matter. Good. So, without asking, I'll answer a few questions. Some of you are concerned about the exam on Wednesday. Okay, so as a reminder of the way things work, by the end of the semester, we will have done about 140 WEXs, approximately. Approximately 40 of them will be graded out of 10, and the rest of them will be graded as completion, and they're worth 1 point. So, to be clear, you have a WEX grade that would therefore be, well, if there's 40 that are out of 10, that's 400 possible points. And if there's a further 80 that are out of 1, that's a further 80 points. So you have approximately 480 possible WEX points. Your WEX grade will be the percentage of whatever you got. So maybe it's the case that you get 428 out of 480 possible points. Whatever that is, that would be the percentage. So currently, well, by the time the exam is graded, that will mean that there are, I think, 23 or 24 out of 10 WEXs, and about double that completion WEXs. That's what that would mean. So that's how your WEX grade is computed. Now, the reason why we have the reason why the midterm and the final exam, because the final exam is going to be just the same, are made the way that they're made. So I asked those 3 questions that many of you found difficult at the beginning, because the 20 WEX questions that you already did that were subject to redo on the midterm, that's like 20 separate topics, and they're sort of pointed, right? This WEX is just that topic, that WEX is just that topic. The purpose of those 3 questions is in order to faithfully measure your knowledge, I need to measure you attempting to do more than one thing at the same time. Because it's great if I always ask you to do one thing, you can always do that one thing. But I need to see if I ask you to do 2 things, if you can do them both at the same time. So that's the purpose of those questions. The purpose of the redo is that, from a teaching point of view, I don't really care if, on the day of the quiz, you didn't know how to do it. And I don't really care too much, I care a little bit, if you didn't know how to do all those things on March 7th, 2 days ago. That's a concern, fine. But if you can do it on May 4th, then we're square as far as I'm concerned. So on May 4th, or around there, it may not be exactly May 4th, that's our final exam. We're going to have a final exam. It may not be exactly May 4th, so don't write that in your calendar. That exam is going to be 2 hours and 45 minutes. And you're going to have lots of time, right? So then there'll be, again, 3 or 4 questions that are cross-cutting, where you have they'll be completely new to you, and you'll have to solve new things for the first time. You'll again have a chance to redo the last half of the Wexes. So we'll do another 40 or so, another 20 or so out of 10 Wexes in the quiz. And I would be happy for you to have another chance to have a stab at those 3 on the exam. Because in the end, I don't really, what I'm saying is that the 3 that gave so many of you heartburn on the exam, I'll give you something like those on the final exam, and if you can pull it out of the fire then, that'd be great as far as I'm concerned. Because I don't need, like I said, I don't need you to know it on March 7th. I just need to report to the university and the world at large whether or not you know it by the time you leave. Good.
That will make my dad very happy. I was telling him kind of what it was like, and he was like, well, can you redo those 3? And I was like,
I don't know.
I will report that too, though.
Good. Yes? To Galaxy? Well, it can't include the exam because I have to submit it like a week ago. So I'll submit it today. It'll include everything, basically everything up to and including WEX 19, X 190, 1 and 2. So it's likely that you're. I don't even like midterm grades, honestly. I think that I don't really understand why we do them. At any rate, it's likely that your true grade will actually be higher than that because you all will have submitted redos. So your true grade is probably going to be higher than what I have to submit to the university. Other questions? Yes?
I think I'm still confused between the difference between the WEX homework and a WEX quiz.
Mm-hmm.
Because
Okay.
what I wrote down for my redos, the list I brought, out of the 10 that I wrote down, there was only 1
Okay.
that was an option.
All right.
So I think I just misunderstand
Okay.
when I hear you say WEX, if you're talking about.
I get it. I'm writing an explanation right now.
Okay.
So there's 3 WEXs. For example, these 3. These all correspond to Lecture 9. You can tell that they correspond to Lecture 9 because their prefix is 09. These 2 you did as a homework. And on the same day that you turned these in, you did this as a quiz. And there's nothing special about 9. We've done this for all of them. Then I take these 3 and I select just one of them to be graded out of 10. Usually it's the quiz, but not always. Just one is graded out of 10. The others are completion. So, I don't. Usually it's going to be this one is worth up to 10, and each of these are worth up to 1. But for sake of argument, and just to make the point clear, I could make this one out of 10, and these 2 out of 1. I usually select this one because this is the one that I can be sure that you did, right? Because conceivably you could just download these and send them over to your friend who's quite excellent at math, and you know what I mean. I'm not accusing anyone of anything. I'm just saying I know that you did these. But sometimes either because I forget the quiz or I don't like the question on the quiz, I like that one, I grade one of those out of 10. And all of that, which ones are graded out of 10, this is all marked down on the calendar. So which is which is on the calendar. where it says, here's all the x's, this was the date it was done on, this was the topic, and was it graded out of 10 or was it completion? And I don't announce what it's going to be because, well, if I announce in advance which one's going to be graded out of 10, then you can make a calculation in your head and say, I'm not really going to, I'm not going to try that one. It's only worth 1 point anyway. So I withhold the announcement until it's too late for you to use that information to alter your behavior. Other questions? Good. So we've got to get to business. Okay. So last time we were talking about completing the square. And we did that several times. The first couple of times we did it, the polynomial was monic. Then we did it for an example where the polynomial was not monic. That is to say, the leading coefficient was not 1. That was a little bit extra tedious when it wasn't monic. Now we're going to make a remark. It's going to be a long slog of a remark, but it's going to be, in a sense, completing the square once and for all. Like, let's not ever do it again. Okay. So let ax squared plus bx plus c be equal to 0 with a not 0. Okay, and for this remark, two things. In the first place, it's going to be just, well, it's going to be one of the more complicated things we do all semester. But as we're going through it, I want you to try and relax, because I'm not going to ask you to repeat what I'm saying, but I am going to ask you to repeat the punchline. So you've got to remember the thing at the end. Okay. And I have to go fast because we talked about the exam so much. Okay, so notice that this is not monic. It's not monic because the leading coefficient is a, and we want it to be 1. So the way that we're going to fix that is by dividing both sides by a. You can divide both sides by a because a isn't 0. It would be undefined to do that if a was 0. So the right-hand side is 0, because 0 over a is 0. And if you divide the a into each term, the terms become x squared plus b over a multiplied by x plus c over a. So the penalty for having a non-monic quadratic is that now we have fractions. So when you complete the square, remember what completing the square is you add something and then subtract the same something. And in particular, you sort of ignore the thing that doesn't have x. So I'll just cover it up. And that coefficient right there, b over a, we're supposed to take half of that, square it, add that much, and subtract that much. That's what completing the square is. So x squared plus b over a x. And then now, here's the complete the square magic, plus b over 2a squared minus b over 2a squared, oops, and then plus c over a equal to 0. So that red stuff, I added that much and subtracted that much, so that's a fancy way to write 0. Then, when we were completing the square, I always went on to say, and now look at these 3 terms. And what was it that we did with these 3 terms? These 3 terms factor. And they factor in the nicest possible way. They factor to something that looks like, well, it looks like something squared. Because remember, completing the square, I started to write something. I can't erase it because it's in pen. So it's going to look like something squared. The question is what is being squared?
First thing
Uh-huh. X.
plus
Yes?
square root of the second thing.
Right, that thing right there. So b over 2a. So completing the square, you always end up with that square there. Then minus b over 2a squared, and then plus c over a is 0. So now we've done a few algebraic steps, and I want to remind you that in the end our goal is to solve for x. Notice that these ones don't have any x's with them. So I'm going to just move them over to the other side since we're trying to solve for x. So it would look like x plus b over 2a all squared is equal to, moving that over, that would be b over 2a squared and then minus c over a. Now, we're going to ignore the left-hand side for a moment and just work on the right-hand side. So, in particular, the first thing I'm going to do is I'm going to distribute the square to numerator and denominator. That is to say, I'm going to make a step that looks like this. W over z to exponent n is w to exponent n over z to exponent n. So I'm going to give the exponent to the numerator and also the denominator. The numerator is easy enough, it's b squared. As for the denominator, can you do it in your head? What would you get if you squared the denominator?
4 times a squared.
Very good. And then subtract c over a. Now, I want to combine these two into a single fraction. So this 4a squared, that's 4aa. Because a squared is just a nice way to write aa. So this is 4aa, and that's just a. So what is this one missing? 4a. So I'm going to say that this is b squared over 4a squared, and then minus c over a. And then this one was missing a 4a, so we'll have to multiply by 4a over 4a.
Now, isn't the left side missing an additional a?
What left side?
Um,
Over here?
no, the left side of the right side, the 4a squared. Like,
This?
yeah, when you look at the two denominators, the one on the right has an a. So now that one, well, I guess in my brain I'm thinking about when we did it in the past, we always multiplied 1 by both sides. Something equivalent to 1 for the left and something equivalent to the one on the right. You see what I'm saying?
Okay, I think I see it. So what I'm saying, do you agree that this one is 4aa
Yeah.
and this one is a?
Yeah.
So this one, in a sense, is not missing anything.
That's right. Yeah, I get it.
So
That's the reason we don't, is because there's nothing to multiply to the left.
right, you could, if you liked, imagine put a 1 over 1.
Right. Okay.
So this would be b squared minus 4a squared, and then minus 4ac over 4a squared. We've achieved making the denominators the same. So now we can combine the numerators. This would be b squared minus 4ac over 4a squared. And I'll carry this thing down, which we were ignoring, but it was there the whole time. That Oops. Is that. So the numerator, b squared minus 4ac, that's really important. I'm not going to say why yet, but I just want to stick that in there just for now. We've been in this position lots of times where we're squaring something and trying to get something else. Now, the algebra looks a little bit intimidating, but I want you to see that in the end, we've done this so many times before. We're squaring something and we want to get something else. So if on the right-hand side I was covering up a 10, we'd be asking, what could you square so that you'd get 10? Or negative square root of 10. If I was covering up a 16, a 4 would work, or a negative 4 would work. If I was covering up a giraffe, then we'd need the square root of giraffe or negative square root of giraffe. The fact that this looks complicated is don't let it scare you. What's got to be, I'm hiding what we're squaring. It's got to be either the square root of that or negative square root of that. It couldn't be anything else. So the possibilities split now. It could be the case that x plus b over 2a is negative square root of all that mess or it could be the case that what we were squaring is the square root of all that mess. We're about halfway done. Okay. So now I'm going to work on just this bit for a moment. So just that much. But keep in mind that currently the possibilities have split into two branches. So there's one possibility and the other possibility. So now observe that the square root of b squared minus 4ac, and again, for those of you who are starting to feel anxious, please remember that I said try to relax. It's the punchline that you need to remember, not all of this stuff.
Now this isn't the negative version of that. This is the positive version?
Right.
But okay, I'm sorry to be like annoying,
Mm-hmm.
but I feel like you pointed to the left side, to the left or.
Well, so still, I could be covering that up. That could be an 8. So we'd be saying negative 8 or
Okay.
8.
My question then is irrelevant. Yeah, okay.
Okay.
Yeah.
Good. So now we're going to use one of the rules of radicals and distribute the radical to numerator and denominator. Specifically, the rule that we use there is that the square root of w over z, where the fraction is inside the radical, is the same as the square root of w divided by the square root of z. Now the numerator, we're finished with it. It's not going to change anymore. It's done. But the denominator is going to be subject to a little bit of work. We can simplify it a little bit. So notice that there's a 4 in there. The 4 can come out of the radical. How does it come out as? 2. And there's an a squared it also can come out. What does it come out as? Not A.
Absolute value of A.
Absolute value of A. Sometimes I imagine, because I teach college algebra a lot, actually. I imagine getting a little button here that has a counter, and every time this every time this comes up, I can click, and then right now the number would be reading something like 39, right? How many times has this come up? A lot. Okay. This is because the square root of A squared is the absolute value of A. Okay, now, recall the definition of absolute value. That the absolute value of A is, well, some of the time it's A when something, and some of the time it's actually negative A when other something. So, under what circumstance is the absolute value of A equal to A?
A is greater than 0.
Right. In fact, I'll cheat, not even cheat, but just combine just slightly and say greater or equal to 0. And the absolute value of A is negative A when A is negative. So what I mean by that is, according to this definition, what it's saying is that the absolute value of negative 3 is negative 3. Which of course is 3. Okay, so absolute value of A itself has two possibilities. So what I'm saying is that this was an aside. We were here, and now we're coming back. And there were two possibilities, and each one of these possibilities is going to split into two possibilities. So then there's going to be 4 possibilities. So now, back at it, we have that it is possible that x plus b over 2a is negative square root b squared minus 4ac over 2 absolute value of a, or x plus b over 2a is square root b squared minus 4ac over 2 the absolute value of a. So those are our two possibilities, and now each one of these two is going to split into 2. They're going to split into 2 on whether or not a is negative or positive. So in the case that a is negative, if a happens to be a negative value, then this would imply that x plus b over 2a, and again, for those of you whose your anxiety level is rising, I can practically feel it. Remember, we got to remember the punchline. Not all of this work. Negative square root of b squared minus 4ac over 2 times, well, this is the time we're considering that a is negative, and as a result, the absolute value of a is negative a. The other possibility, we must press on. The other possibility is that x plus b over 2a is negative square root b squared minus 4ac over 2 and just a, because that's the possibility when we'll say that this one is the possibility when a is positive. So this one thing split into these two things. And now this one thing is going to split into 2 things. So this one will be the possibility when a is negative. So when a is negative, this would become square root b squared minus 4ac. And because we're talking about the possibility that a is negative, this would be 2 multiplied by what? Negative a. Because isn't it the case that the absolute value of negative 10 is negative 10? Yeah, okay. This one. B over 2a equal the square root of b squared minus 4ac over just 2 regular a. All right, now it's almost out of control. 4 possibilities. 1, 2, 3, 4 possibilities. But I'd like to ask a question. Is it the case that negative 13 over 14 is equal to 13 over negative 14? Is that true? That is true, right? That's true. All right. Then please tell me about these 2 possibilities.
One can be negative on the outside, one positive.
So the only difference is the location of where the negation is, right? This one is saying that the numerator is negated. This one is saying that the denominator is negated. Otherwise, everything else is the same. So what's true about these 2? They're equivalent. Those are actually the same. They're the same for the same reason that these 2 are the same. Okay, here's a different question. Is it the case that 13 over 14 is equal to negative 13 over negative 14? Is that true? That is true. Now tell me about these. Well, this one, the numerator is negated.
But the denominator isn't. Oh, it's in that same one.
Yeah.
Okay.
So the negation in the numerator and in the denominator cancel in the same way that these cancel. So these 2 are the same in the same way that those are the same. So there's 4 possibilities, but not really. There's actually just 2. Therefore, x plus b over 2a is negative square root b squared minus 4ac over 2a, or x plus b over 2a is square root b squared minus 4ac over 2a. So notably, the left-hand sides are exactly the same, and the right-hand sides are exactly the same, except that one is negated. Otherwise, they're the same. Again, the task was to solve for x. So now finally, this b over 2a is going to go over there and be with its non-x buddies. So x could be negative b over 2a plus negative square root b squared minus 4ac over 2a, or x could be negative b over 2a plus square root b squared minus 4ac over 2a. And finally, I'd like for you to observe that in both possibilities, this is something over 2a plus something else over 2a, and this one is something over 2a plus something else over 2a, so they can be combined into a single denominator, and we can arrive at the punchline, the part that you're supposed to memorize. So x is negative b minus the square root of b squared minus 4ac over 2a, or x is negative b plus the square root of b squared minus 4ac over 2a. The punchline. So this punchline is significant enough to have its own name. The name for this is the quadratic formula. This is the quadratic formula. Which solves every a times x squared plus b times x plus c equal to 0, and such a thing is called a quadratic equation. So now, just as a little bit of terminology, this one is the one called the quadratic formula. That one is the one called the quadratic equation. The quadratic formula is a tool which is used to work on a quadratic equation, in the same sense that a screwdriver is a tool that is used to work on a screw. That being said, a large fraction of students refer to this as the quadratic equation. It's not. This is the quadratic formula. This is a quadratic equation. And that error is the same kind of error as, you know, like that light switch over there has little screws on it to hold it in place. It would be like calling the screws a screwdriver. It's the same error. That being said, I'm not going to count off or anything. I'm just letting you know that you sound silly when you say it. Good. So let's solve with the quadratic formula. We'll solve with the quadratic formula. 3 times w squared minus 5 times w minus 7 is equal to 0. So the method was explicitly requested, so that's what we must use. In order to use the quadratic formula, you need to identify the values for a, b, and c. So in this specific exercise, what are their values?
A is 3.
Good. 3.
B is negative 5.
Yes.
C is negative 7.
Very good. So notably, I'd like for you to observe that this is an equation you could solve by completing the square. You could do it. Quadratic formula doesn't open up anything new to you. I mean, after all, the quadratic formula, we literally got it by completing the square. That's how we did it. And also note that the name of the variable is not significant. For example, there's no x's in this problem, only w's. So there's two possibilities. W could be negative 5, subtract the square root of negative 5 squared minus 4 times 3 times negative 7 over 2 times 3. That's one of the possibilities. The other possibility is that W could be negative 5 plus the square root of all that mess, negative 5 squared minus 4 times 3 times negative 7 over 2 times 3. So that mess in the radical, that's calculator work there. So I'll do that real quick. So that would be negative 5 squared minus 4 times 3 times negative 7, which my calculator promises me is 109. So this would be W is 5, because negative 5 is 5, minus the square root of 109 over 6, or W is 5 plus the square root of 109 over 6. Beautiful. It's like the quadratic formula is like a big tool, like if you've ever had the pleasure of building a fence or something like that and dug a fence post hole and dug it with a shovel. Yeah, it can be done. But it's real nice if you have a post hole digger. It's kind of
an auger.
That's what I meant. Yeah, an auger. Yeah, an automatic one.
Yeah.
That's what this one is.
So the denominator will always be 2 times the leading coefficient?
Yes, 2a. Mm-hmm. Yeah, because that's the formula. Okay. Good. So now we're going to switch gears for a second. It's going to seem strange. We're going to sort of sharply change directions for just a moment. So in particular, I want you to consider y equal x squared. And we're going to make a table. So negative 3, negative 2, negative 1, 0, 1, 2, 3. So essentially all that I'm asking presently is for you to square those numbers. So I'll do it quickly. That would be 9, 4, 1, 0, 1, 4, 9. I'd like for you to observe that these read the same forward and backwards. When you have a string of items that are the same going forwards and backwards, such a thing is called a palindrome. That's not a math term. Palindrome like race car and taco cat and things like that. We saw another thing just like this where it was a palindrome. It wasn't y is x squared though. What was it? Nope. Or at least that's not the one I'm referring to. The one I'm referring to is absolute value.
No, that's right. Yeah.
So it also was a palindrome when we did it like that. And what's the shape of absolute value?
It's going to be very similar to the shape of this, right? Yeah. It's a V.
It's a V. The fact that absolute value is a palindrome is witnessed in its symmetry. as a V. This is a palindrome. It also will be symmetric, and it will be kind of like a V, but not exactly. It will be V-ish, I suppose. Normally, I make the tick marks be 1, but so I can get all this to fit, I'm going to make the tick marks be 2 so that halfway is 1. So 0, 0, 1, 1, 2, 4, and 3, 2, 4, 6, 8, 9. Kind of looks like it, but not quite. So there's 7 points. And if we plotted lots and lots and lots of points, you'd see that it's a little bit bendy. Kind of like a bendy V-looking thing. But bendy V-looking thing is not a good name for it. And furthermore, this shape occurs so often in nature and science that it has actually its own name. What's its name? Parabola. Okay, so in fact, every quadratic plot is a parabola. Now, don't misunderstand. I don't mean every quadratic plot is this parabola. I mean is some parabola. So now, remark, we're going to classify parabolas in 2 ways. So we'll say let y be ax squared plus bx plus c, with a not 0. So the first classification is down versus up. So ignoring the axes, the xy axes for a moment, all parabolas either look more or less like this or like this. Qualitatively, we'll refer to this as this opens down. And we'll refer to this one as opens up. But that's a visual thing. The question is what does that have to do with the algebra? Well, the leading coefficient a, all parabolas that open down have a negative leading coefficient. So like negative people, are they smiling or frowning? Negative people. They're frowning. So, wow. That even kind of looks like a frowny face, doesn't it? Negative, frowny, downy. Good. This one is the other one. Next is we're going to classify them on the number of x-intercepts. And this will be the last thing that we do. So down versus up, there were 3 possibilities. But in the number of intercepts, there's actually, there's 2 possibilities up here. For this one, there's actually 3 possibilities. So remember that x-intercepts, that's where you touch the horizontal axis. So concerning this parabola that I've just drawn, my question is, how many x-intercepts does it have?
Which one did you point?
This one.
You switched it. Okay. It depends on where it crosses, right? I mean, if it's at the very...
Where does it touch the horizontal axis?
Oh, that particular one doesn't.
Doesn't, right? Okay, good. So number of x-intercepts for this case is 0. Now suppose I grab hold of that parabola and just bring it down to just rest on top of the axis. In this case, how many x-intercepts are there? Exactly 1. And then if I pull it down any further whatsoever, then there will be 2. And that's easy enough to understand because the human visual system is excellent. And the last thing we have to say before the break, I know we're coming right up on the clock, but I got to say it, is how do you qualitatively figure this out algebraically? How do you figure it out algebraically? Okay, well, in the quadratic formula, and while we were figuring it out, I said b squared minus 4ac is important. And here we have it. D equal to b squared minus 4ac in the radical of the quadratic formula is called the discriminant. So on this example, the discriminant was 109. If the discriminant had been negative, we would have had to say that there was no solution to this exercise, because the exercise would have been a real exercise, and we'd say, oh, you just can't do it. So there'd be, how many solutions would there be? If it were negative 109? There'd be none. What's true about the discriminant here?
Well, it's a negative value.
When d is negative. This is also when the number of real solutions, we're 30 seconds out, I promise. The number of real solutions is 0. In this case, well, this is when d is positive. And the number of real solutions is 2. What is the last case?
D is 0?
D is 0. And the number of real solutions is exactly 1. And by the end of Monday, we'll know everything that there is to know about quadratics. Have a nice break.